Hello everyone, welcome to Josh Max channel. In this video, we are going to see for CBSE Maths Grade 12 Standard Chapter 5 Continuity and Differentiability in Exercise 5.1 19th sum. So already in the last videos, I have uploaded solutions till 18th sum. Now let's start with the 19th one. Okay, so here show that the function defined by g of x equal to x minus greater integer of x is discontinuous at all integral points. So the given g of x is discontinuous at all integral points that we have to prove it. And what is the greater integer of x stands for? That is they have given here. Okay. And before showing the proof, so we can move, let's study about what is greater integer function. So some small intro about it, then we can prove the given part. Okay, so now you can notice that this is the greater integer functions graph. It's not the given g of x graph. It's a greater integer functions graph. That is, okay, let me take f of x equal to greater integer of x. Okay, so you can notice that at every integer, the given function is discontinuous. Okay, so between two integers, we have infinite real values, right? So for all the real values, excluding the integers, basically the function is continuous. At integers, the function is discontinuous. With one example, I will tell you. Okay, now let me take 3. And before that, so f of 2, greater integer of 2. Only for the integers I am going to take now, it's going to be 2 itself. Now f of 3, greater integer of 3 is, yes, it's going to be 3. And greater integer of 4, it's going to be 4. Greater integer of 5, it's going to be 5. So for the whatever integer you take, exactly the same integer. But when we take other than the integers, the values between 2 and 3 integers, the real values if we take, suppose f of 2.9, if we take the greater integer of 2.9, it's going to be 2 itself. Okay, now greater integer of 2.3, it's going to be same 2 itself. Now greater integer of 3.5, it's going to be 3 itself, not 4. It's not like a rounding off, it's a greater integer function. So we have 2.9 gives you 2 only. Okay, so now let's check with the continuity for the 3. Okay, let's check the continuity of the greater integer function for the 3. Okay, so now what is the f of 3? If it is continuous, we need 3 things, that is f of 3, left hand limit and right hand limit. Now for the f of 3, greater integer of 3 is what? Exactly, it's going to be 3. Now let's say close values of the 3. That is the left hand limit. Let's say close values of 3, approximately 3. But those values are anyway less than 3. If it is less than 3, it has to take the what is the integer before the 3, that we have 2. So it will take the 2. So answer gives you the 2. Okay, but for the right hand limit, we have a 4 here. Okay, now close values of the 3 from the right side. What answer we will get? 3 we will get it. Okay, now you can see there is a mismatch in the left hand limit and right hand limit. So we can say that the greater integer function discontinuous at x equal to 3. Okay, now same thing applies for all the integers. So at every integer, the greater integer function discontinuous. Okay, now here the combination of x and the greater integer is given. Since greater integer is there, obviously it is going to be discontinuous. So now given g of x, and we have how many integers throughout the real line? Infinite real numbers, sorry, infinite integers. So we can have a common name. Let c be any integer. So any variable is fine. Okay, let c be any integer. Now g of c, so that means in place of x I am going to replace c. So c minus greater integer of c. So c be any integer? No. So whenever we take the integer, the same exact value only, the result you will get it. So greater integer of 3 is 3. Greater integer of 2 is 2. So greater integer of c is what? It's going to be c only, since it's an integer. Okay. So c minus c, which is 0. Okay. Now left hand limit of the c we are going to find out. Limit x is approaching to the c from the left side, g of x. What is the suitable g of x here? Only one we have, that is x minus greater integer of x. So limit x is approaching to the c, g of x is x minus greater integer of x. Okay, now let's apply the limit over here. Then c minus greater integer of c. Okay, now you can understand one thing. So left side close values of the 3, what value we got? 2, that is 3 minus 2. So less than 1 value. So it will be, we have to subtract 1 to the c, 1 from the 3. So same way here, uh, C is any integer, the left hand limit always gives you one value less than the integer. So that means C minus, here the greater integer of C gives you C minus 1. Now this minus sign is common for both the terms. So C minus minus C, then minus into minus plus 1. So C get cancelled, the result is 1. So here the left hand limit is 1. Now same way let's find out right hand limit. Okay, here itself I'll do. Now for the right hand limit. Now suitable function. So limit x is approaching to C. Here only one function we have, that is g of x. What is the g of x here? We'll replace it. G of x is x minus greater integer of x. Now applying the limit C minus greater integer of C, and here greater integer of C, what we have to replace, that let's check it. So now right side closed values are greater than 3. Okay. So which value we have taken here? 3 we have taken. That means for any integer, the same integer it will take it. So 3.5 also 3. That means any value for the, if it is integer, the right side closed values of that integer, I mean for the real values, what will happen? It will take the exactly C itself, and the left side closed values it will take C minus 1. Okay. So here C takes C only. Greater integer of C is C only. So now from this what we got, that is 0. So now you can notice that left hand limit, right hand limit are not equal. So from this what we can say, the given g of x, that is x minus greater integer of x, is discontinuous at all integral points. Okay, integral points means integer. So therefore g of x equal to x minus greater integer of x is discontinuous for all integral points. Hence proved. That's all. Thank you for watching, and please do subscribe. Thank you.